Hi, grade 11. Today we're doing lesson 6.6 and 6.7, which is modeling periodic phenomena and solving problems using sinusoidal models. So they're both short lessons, so I'm just going to combine them. So the handout on Teams that you should print, you should have that in front of you now. So we're going to start on lesson 6.6. It says, given the following data, determine the equation that would be the simplest model for this data. So we need to find an equation given these numbers. So we're going to start by graphing the data. So you have a graph given for you there. I'm going to draw one here. So on the y-axis, you're going to go up by ones up to 8. You don't need any negative y values for this one. So I'm just going to use every other line just so that it's a little more spread out. But you can use every line on yours. And then on the y-axis, every other line is going to be 45 degrees. So 45, then skip a line, 90, skip a line, 135, 180, 225, 270, 315. And then also the negative side, negative 45, skip a line, negative 90, negative 135, and negative 180. All right, so we start at negative 90 and we go up to 8. Got a point there. Negative 45, 6. 0, 4. 45, 6. 98. 135, 6. And 184. And then we're going to connect these lines with a smooth curve. All right. Now we need to create an equation for this curve. So we can either use sine or cos. So I'm going to show you how to do both so that you know. So if we choose sine underneath the graph there on the left side, so f of x equals a sine bracket k bracket x minus d plus c. A is the amplitude. The period is 360 divided by k. The equation of the axis is c. And the phase shift is d. So we'll start with the period. If we look at our graph, to go from the lowest point to the next lowest point, that's 180 degrees. So the period is 180. So then from that we could find the k value, because k equals 360 over 180. That means k equals 2. The amplitude is the difference between the highest and lowest y value divided by 2. So the highest y value is 8. The lowest y value is 4. So we need to do 8 minus 4 divided by 2, which is 4 divided by 2, which is 2. So a is 2. So we have k and a. To find c, the equation of the axis, that's halfway, the halfway y value. So if a is 2, we go from the amplitude is 2, We go from the highest y value and we subtract 2. So that equals 6. Or we could go from the lowest y value and add 2. So the equation of the axis is y equals 6. And that's our C value. Now, if A is positive, so this graph is not reflected, then typically sine starts at the middle and goes up and then continues. So that means if it started here, it has shifted to the right 45 degrees. So we have a phase shift of 45 degrees, positive. Now we're going to plug these values into the equation, and then we'll have the final equation. So f of x equals a, the amplitude is 2, and we went with a positive a value so that we could have the positive shift. 2 sine, bracket, k was 2, bracket, x minus, the original equation is x minus d. So because we're putting in a positive 45, we write x minus 45. And then the c value is 6, so plus 6. And that's the equation for this curve if we're using sine. Now we can also create a cos equation for the same curve. F of x equals a cos kx minus d plus c. So the amplitude will be the same, equals 2. So that was the highest point, 8, minus the lowest point, 4, divided by 2 equals 4 over 2 equals 2. The period will also be the same, 1 cycle. So that was 180. So k equals 360 divided by 180, which equals 2. And the equation of the axis will also be the same. And that was 6. So if A is positive again, cos starts high and goes down, like this. So that means now we have shifted over 90 degrees. 90 degrees positive. So now we'll just plug these numbers in. Or actually the other option, so we could have a positive 90 degrees phase shift, or if we just reflected this curve, flipped it over, then it would start up here and go down. So then there would be no phase shift because cos would be starting high and going down. So we can either do a positive 90 phase shift, or if A is negative, there's no phase shift. So that is actually simpler than having a positive 90. So we would now make A to be negative 2. So our final equation is f of x equals negative 2 cos bracket 2 is the k value, x bracket plus 6. Okay, now on to the next handout, lesson 6.7. So the beginning key ideas in the box there, it's going to be a bit of repetition from what we just did. It says sinusoidal functions are useful for modeling real-world problems, including periodic behavior. So method, determine the amplitude, period, equation of the axis, and phase shift from the data. Insert the 4 transforming parameters into either the sine or cosine equation. Note, because these functions are repetitive, there will always be an infinite number of possible equations that will model the situation. The key is to find the simplest equation. So that's kind of like what we just did there. So there's just one example here. At the 2018 spring banquet, Ethan went for a ride on the Ferris wheel. Its maximum height was 11 meters from the ground, and its lowest height is 1 meter above the ground. Ethan's friends recorded that it took 10 seconds for him to reach the highest point and 55 seconds for him to reach the lowest point on the ride. Model Ethan's height over time using a sinusoidal equation, then calculate his height after 78 seconds. Alright, so we're going to start by drawing the graph. So we don't need any negative x or y values because he's not going underground, and he's not going back in time. So on the y-axis, this is going to represent his height in meters. We are going to go up to 10, so every line is 1. So start here, 1, 2, 3, 4. And this is height in meters. And then on the x-axis, we're going to go up to 100. So I went up by 5s, so 5, 10. And this is representing time in seconds. And then we're just going to plot what we know. So from the question, it says his max height was 11. Oh, sorry, I guess you need to go up to 11, which your paper does. His max height was 11, and his minimum height is 1. So it took 10 seconds for him to reach the highest point. So after 10 seconds, he's at 11 meters. So let's mark that point, 10, 11. And it took him 55 seconds to reach the lowest point on the ride, which is 1. And then, of course, he kept going up and down. So that means halfway between 55 and 10 would be 55 plus 10 divided by 2 would be 65 divided by 2, which would be 32.5. So halfway between that, he'll hit the halfway height, which is 11 plus 1 divided by 2, which is 12 divided by 2, which is 6. So another point that we know is 32.5 seconds. We'll put him at a height of 6 meters. And then after the 55 seconds, 32.5 seconds later, he'll hit at 6 again, which is 77.5. And then 32.5 seconds after that would put him at 100, and he'll be back at the top, which is at 11. So 100, 11. And then we're just going to connect those with a smooth curve. All right, so I'm just going to draw on here a dotted line at 6 because that's the axis, equation of the axis. And then you can see that that's kind of like the middle. Okay, so we've graphed it. Now we're going to create an equation. So we're going to do both cos and sine, that you can see. So first we're going to use cos. So we're going to find the amplitude. The amplitude is the difference between the highest and lowest point divided by 2. So difference is subtracting. So 10 divided by 2 equals 5. So the amplitude is 5. The c value, or the equation of the axis, is at 6. We could calculate that by doing 11, which is our highest point, minus the amplitude, which is 5, equals 6. Or you could take your lowest point and add the amplitude, equals 6. The period equals 360 divided by k. We need to find k. How long does this take to do one complete cycle? So we start at 10 and we end at 100 again, and that's one cycle, so that's a total of 90. So 90 equals 360 divided by k. We can solve for k by multiplying both sides by k. These ones cancel out. Now we have 90k equals 360, divide both sides by 90, k equals 4. And then our d value is our phase shift. So we're using cos. Cos starts up high at the top and goes down. So normally it starts at 0. Now we're starting at 10. So we have shifted 10 right. So that would be plus 10. So now if we just plug these numbers into the equation, y equals a cos k x minus d plus c. Then we have y equals 5 cos bracket 4 x minus 10 plus 6. Remember that we use minus 10 because the original equation is minus d. We're plugging in 10 for d. If we were using sine, a lot of the information will be the same. So a still equals 5, k equals 4, c equals 6. And then d, the phase shift, if this line continued and we kept going this way, then we would hit the middle point, which is where sine starts, at negative 12.5. Because we would have to go back 32.5 from this. Sorry, we would have to go back 45 from this 32.5. Back up 45 because this difference here is 45. So plugging this information in, we'll have y equals 5 sine bracket 4 x plus 12.5 because we're inserting a negative plus 6. And that's the equation. Now, the third part of this is find or calculate Ethan's height after 78 seconds. So we're going to use one of the two equations we made. They will both produce the same answer after 78 seconds. So we're going to plug in 78 for x. Let's use the cos equation. So y equals 5 cos 4 x minus 10 plus 6. I'm going to insert 78 for x. So we'll have y equals 5 cos 4 78 minus 10 plus 6 equals 5 cos bracket 4. 78 minus 10 is 68. 4 times 68 is 272 plus 6. These three terms are multiplied. 5 times cos 272. So plug that into your calculator and then add 6 and you will get 6.17 meters. And if you use the sine equation, you will get the same answer. All right? So that's today's lesson. Let me know if you have any questions and good luck with your homework.